Before we start with our last stuff, let's take a moment and review. And you don't have to write this down, just putting it out there. The first type of conic sections that we talked about were parabolas. Parabolas that could be either vertical or horizontal. What was our geometric formula for a vertical parabola? What did that look like?
X squared over...
Nope, these are parabolas. What did parabolas look like?
Parentheses, X minus KH.
Always H.
Squared plus
Equals
minus, oh, dang.
4p.
Oh, now I remember.
Good. Okay, so this was our geometric definition because it looks so different than our college algebra one that we were used to. Okay, so when it's vertical, the x is the only thing that gets to be squared. When it's horizontal, that looked like what?
Y minus k.
A y minus k is squared. And then over here, you still have that 4p. X minus h. Good. And what does the h comma k represent for a parabola? Not the center, because it's a vertex. Good. So in this one, h comma k is your vertex. Okay. All right. Then we talked about, well, to be honest, we did circles last year. Okay, so if it's a circle, what gets to be squared there?
Both.
Both of them, okay, and our x minus h squared plus y minus k squared equals what? R squared. Good. And in this case, h comma k represents what for a circle? The center. Okay. And our r squared, when you square root it, is r, gives you your radius. Okay. All right, so we did parabolas, we did circles, then we talked about ellipses. Okay. So when it's ellipses, I'm not going to have enough room here. Hold on, I got to erase. Wish I was working with this one. Oh, I wish I had a smartboard. All right. For ellipses, if it was a horizontal ellipse, what did that look like?
X squared over a squared plus y squared over b squared equals.
Good. Okay. Now, if the center was not at 0, 0, then what went on top of that a squared? X minus h, for it to be horizontal, and then here, y minus k. Okay? And where this is your bigger number. For it to be a vertical.
Same thing except for the a squared and b squared are switched.
Good. Just making sure everybody's okay.
He's given up on Rachel coming in.
Fair.
I gave up at the very beginning of class.
Okay, so, dang it. How are circles and ellipses different?
They equal 1.
Ellipses equal 1, whereas circles equal what?
R squared.
R squared. But like this setup, the whole x minus h squared plus y minus k squared is very similar, right? Okay, and on both of these, the center is that h comma k. All right, so we've dealt with just x being squared is a parabola, up and down. When just y is squared, it's a parabola on its side. If they're both squared, it's either a circle or an ellipse. What's really the one thing that we haven't dealt with?
If there's the outside parentheses on the top and it can't be reduced.
Wait, if the x or y squared is on the bottom.
True, but we're not going to get that intense to it. On all of these problems, there's always been a plus sign.
Oh.
Okay? If it's subtraction, that's when you get a hyperbola. So in your notes, let's go ahead and write down, not that, that's algebra 1. Let's write down a hyperbola definition. And so a hyperbola is a set of all points in a plane such that the absolute value of the difference, okay, so difference meaning subtraction, of the distances from two fixed points is constant. The two fixed points are called our foci of our hyperbola. And again, you can have a hyperbola that opens left and right or up and down. We still have foci, we still have vertices, we still have a center, and excuse me, now we also get to have asymptotes. And this is our last day of learning new content.
Nice. Love it. Thank goodness. And we aren't even gonna have homework. It's great.
What?
You said yesterday.
Did I?
Yeah, because it's Friday we have prom.
Right, I did say that. Okay, I'm thinking about it. Sorry. They've got an EOC next week, so they don't have problems. They still get this.
Thank you.
Any of the following students, please come to the office. Hunter Burns, Wade Cooper, Jordan Gray. Thank you.
So this is kind of different because the foci is outside of the vortex.
Rather than on the inside. But that's also because the hyperbolas are opening away from each other instead of towards each other. Whereas all of our other shapes, they curve towards each other to connect. Hyperbolas do not connect. This one over here, since it's the vertices and the foci are on the horizontal line, and it's opening left and right, this is what we'll call a horizontal hyperbola. And this one, since your foci and vertices are on the y-axis, and it's opening up and down, is what we'll call a vertical hyperbola. Everybody good? Tim, you good? Okay. So, let's take a look at the equation for this. So if you're dealing with a horizontal hyperbola whose center is at 0, 0, and the foci are on the x-axis, our equation is going to look like x squared over a squared minus y squared over b squared equals 1, where your vertices are at a, 0, negative a, 0, and your asymptotes are y equals plus or minus b over a x. Excuse me. All right. You also notice that finding c on this one is different. C squared is actually a squared plus b squared. That's not how you spell that. I just kind of paraphrased it over here because I like to have it in front of me when I start doing examples.
And here I thought the reason on the parabola thingy, or no, the ellipsis, it was c squared equals a minus b, is because that's how you find a triangle side, is that way.
It's still a squared plus b squared equals c squared.
Yeah, I know, that's why I thought that the other one was the minus, because it couldn't be the same, but this is the same.
Alright, we ready to look at horizontal? I do mean vertical, yeah. Let's write both of them down first. Hey. There we go. Alright, so if it's vertical, how is the vertical one different from the horizontal one?
The
The
focus.
Y's are,
The what?
the Y's are pretty
Well, actually,
The Y's in
the Y's in front. Yeah, the X and Y switch. Whereas when it was an ellipse, it was always X plus Y and the denominator switched, A or B switch. When it's a hyperbola, A and B stay in the same spot, X and Y switch. Okay, so if the Y squared is first, that's going to make it a vertical hyperbola. I like it. Excuse me. I still have c squared equaling a squared plus b squared. The vertices are still found by a, foci are still found by c, but the asymptotes now are plus or minus a over b, x. Hmm?
It's cracking his neck over here.
No.
Break it. What's going on?
Alright, everybody good at this one? Okay, let's look at a couple of examples. so let's take a look at if we've got x squared over 4 minus y squared over 25 equals 1. Again, it's always got to equal 1. So with the ellipses and hyperbolas, they always have to equal 1. All right. Based on the equation, is this going to be a horizontal or is it going to be a vertical? Horizontal, which means we're going to have our hyperbolas opening left and right. Okay? Like that, away from each other. Tiffany, what is in the a squared spot? 4. So this is going to be horizontal. A squared is 4, which means, Tiffany, what is a?
2.
Good. Lexi, what's in the b squared spot? Which means b is going to be what? 5. Good. Now, it does not matter which one's bigger. Okay? What matters is which one comes first. And with the ellipses, it mattered which one was bigger. That's what determined whether it was up and down or left and right. With hyperbolas, whichever variable comes first, that determines whether it's horizontal or vertical. All right. Since we have a, what does that give us on our graph? The vertices. Good. Okay. So since this is a horizontal hyperbola, am I going to go to on the x-axis or on the y-axis?
X.
X. Okay. Here's a vertice, and here's a vertice. Okay. Why can we say that the center of this hyperbola is on the origin?
Because there is no x minus h, x minus no y minus k.
Exactly. It's just x squared on the top, just y squared, so you know your center's at 0, 0. Okay. Our foci are going to be at where?
Out.
To 5. Okay. I'm going to make my foci red. 1, 2, 3, 4, 5. Okay.
Wait, the foci are B in this?
Oh, no, you're right. Good call. They're not. They need to be C. I'm not done yet. I was just going with it, Vanessa. Good call. All right. So, Vanessa, to figure out our foci, we do need to find C. So, what is C squared if A squared is 4 and B squared is 25?
29.
29. Good. So, then what's our C value going to be?
Square root of 29.
Good. Somebody calculate that for me, please.
5.38.
I was close. 5 point what?
39.
5.39. Okay. So we'll go 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Okay, so our foci are going to be about there. And about there. Good. What do we use B for? The asymptote. Good. Okay. So this one is going to have asymptotes that look like y equals plus or minus. What's my b term? Over x. Good. Okay, so my asymptotes are going to be 5 over 2x. What type of a line is that? Linear. Okay, so we're going to graph 2 linear lines here. We're going to graph y equals positive 5 over 2x and y equals negative 5 over 2x. And for both of those linear lines, what's our y-intercept? The origin, okay? And for this one, which way would we go?
Up 5 over 2.
Good, up 5 over 2. So 1, 2, 3, 4, 5, and over 2. I know. There's one of my asymptotes. Your asymptotes are always going to make an x. Then for the other one, you still start at the origin, then you get to go down 5 and over 2. Everyone okay with what we've done on this picture so far? Okay, so now we just have to draw the actual hyperbola. So goes up, runs along the oblique asymptote. Goes down, runs along the oblique asymptote. There we go. Hyperbolas. Let's be okay with everything that's on that graph. Okay. Tim, you okay about the asymptotes?
Yep.
Let's talk about the domain for this.
numbers except. Oh, it cuts in.
It does, okay? We kind of have like this blank space in between our two vertices, correct?
Oh.
So if we have two separate domains, we can write it two separate ways. And what do we just put in between them? A U for union, okay? So Tim, on the left-hand side, how far to the left is that hyperbola going to go?
Parentheses, negative infinity to negative 2 parentheses.
There's actually a dot at that -2, so I'm going to put a bracket.
Okay.
All right. Then we're going to union it and jump over to our next hyperbola. And Tiffany, where does that second hyperbola start at?
Bracket to comma.
Very good, just like that. Okay. Now what about the range? Range is all real numbers. Goes down forever, goes up forever, and there's no like missing chunk in the middle. Very good. Uh-huh.
All I can think is that X is just, the asymptote's gonna keep going with it. Isn't it eventually gonna like cut off that graph at one point?
No, because it'll curve to follow the asymptote.
Okay.
Yep. It'll always stay with it. And since the asymptote's going to keep going down, the graph, or if I keep going down, that curve is also going to follow right along it and keep following it down.
Okay.
Yep. All right. First hyperbola you've ever graphed in your life. Do you feel okay?
Yeah, my graph actually looks pretty good.
Nice. All right, let's do another one. Let's take a look at this one. So if you've got y squared over 9 minus x squared over 4 equals 1. Let's see what type of a hyperbola is this one going to be. Why?
Because the y squared is switched.
It's first. Yeah. Okay, so we're definitely dealing with vertical. Okay. Is our center still at the origin?
Yeah.
Yes, it is. Okay. Vanessa, what's in the a squared spot?
9,
Which means a is?
3,
Good. Tim, what's in the b squared spot?
4,
Which means b equals?
2.
Okay. So then Ethan, what's c squared?
Will you have what they made here the other day?
I don't know. Are they taking all the tables?
Yeah.
Okay. Then, I'll have 3 people in here.
What is the bag for trash?
Oh, okay. Thanks.
And we'll gather it after lunch.
Thank you, ma'am. Ethan, what did you say, c squared?
13.
Oh, 13 here, so yes, square root of 13 here. Thank you. Very good. Vanessa, let's just go ahead and do our asymptote now. Y equals. Now, since this is a vertical one, what's our asymptote going to look like, Vanessa?
it's gonna have the a over the b.
So in this case,
It's gonna have 9 over 4. So
A.
y equals plus or minus 9 over 4.
A
Oh, but a is, 3
over,
over 2.
yes. So plus or minus 3 over 2. Good. Well, all right. Let's start graphing this thing. Lexi, where am I going to draw my vertices? On the x-axis or on the y-axis? Good. I've got 3 and -3 are my vertices. Okay. Excuse me. Ethan, where are my foci going to be at?
0 plus or minus squared 13.
Good. I'm not real great with square roots. Could you turn it into a decimal point, please?
Yeah,
Okay, 3.6. Ooh, this one's closer this time. So 3.6 and -3.6. Something like that for our foci. Tim, where do I start my asymptotes at?
center.
And go where with it?
You can go up and then,
Up and then up how many and over how many?
you go up 3 and over 2.
Good. You basically go 3, up or down 3 and over 2 in every direction on your asymptotes. You go up and over, you go down and over, and then you go up the other way and down the other way. You go, kind of make this nice little box, and then you just draw diagonal lines through them all.
Is there any time that like the asymptote is lopsided? like one side?
No, it will always be a mirror image of itself. Yeah, it should always be a perfect X that is a symmetric, about wherever your center is. Good. And since our parabola is, or excuse me, our hyperbola is vertical, we'll run up and stay within our oblique asymptotes. Very good. And again, the asymptote goes forever, and the graph just stays curved inside of it. Tiffany, what would our domain be for this one? It would be. This one goes to the left and right forever. So on the vertical, our domain is all the numbers. Ethan, what about our range?
Be negative infinity, comma, negative 3, bracket, union, and bracket, 3, comma, infinity, parentheses.
Very good. Everybody okay with those? All right. Let's take a look at one that's centered someplace else. Ooh, here we go. Okay. So if you have y plus 2 squared over 9 minus y plus 3 squared over 4 equals 1. Vanessa, vertical or horizontal?
Horizontal. Vertical.
Y.
Because the y is first.
Good. Vertical because the y is first. Okay. Now, just because the y is first, your center is still going to be h comma k. So for this problem, what is our center?
-3,
Good. That's the nice thing about conic sections is it's always h comma k. Always. For your center or your vertex. That doesn't change. It stays constant throughout. Ethan, what's my a squared term here?
9,
Which means a is?
3,
Tim, what's my b squared term?
4,
Which means my b is?
2,
Okay. Vanessa, what's c squared?
13.
Which means c is?
Square root of 13.
Good. Okay. Our center has changed, so is that going to change where our vertices are? Like it's not just going to be, 3 comma 0, negative 3 comma 0. Or, excuse me, 0, 3, 0, negative 3. So start from your center and count. All right, so we've got negative 3, negative 2. That's our center. Okay. Since this is a vertical hyperbola, to get my vertices, will I count up 3 or will I count over 3?
Up 3.
Up. Okay, so you got to go up and down since it's vertical. Are you okay?
My eye is twitching.
Okay.
I was waiting for it to stop.
So my vertices are going to be at 1, 2, 3, and then 1, 2, 3. Good. So Tim, what are those ordered pairs for our vertices?
negative 3, negative 5,
Oh, yes. And?
negative 3, 1.
Good. Got our vertices. Okay. For our foci, okay, so we're counting which direction? Up and down or left and right? Up and down. It's nice because it's the same as whatever your vertices are. Whatever you do for your vertices, you do the same thing for your foci. All right, so we're going to count up 3.5, so we know it's going to be super close. Not like there. Not here, super close. Now, Vanessa, when we did that, Did the x value of my center change, or did the y value of my center change? Here's my center, here's my focus.
Your y value.
Changed, good. So for our foci, I'm going to leave it as -3, but then say -2 plus or minus the square root of 13. Is everyone okay with that? All right. Now, if our center changes, does that change our asymptote?
Yes.
Yes, it does, okay? Because before, we always just went straight from the origin and counted like up and over whatever we needed to do. Where do we start from? Our center, okay? So we're going to start from our center. Now, this, or excuse me, down here, like this piece, the plus or minus a over b, the slope does not change. Okay, the y-intercept changes, but the slope does not change. So in this case, what is the slope?
Plus or minus 3 over 2x.
Good. So the slope of our asymptote is, m is for slope, plus or minus, what did you say, dear?
3 over 2x.
3 over 2x, good. Okay, so you'll start from your center. You'll go up 3 over 2, down 3, and over 2. And then, again, you're making this nice like box centered around your center. And then you just draw your oblique asymptotes through your center, like that. Are you okay with everything that I've drawn so far? Tim, are you okay with the asymptotes going from wherever your center is?
Yep.
Ethan, are you okay with everything?
Yeah.
Vanessa?
Yeah.
Tiff? Okie dokie. So the last thing I need to do is include my hyperbolas.
Domain and range.
What would the domain for this be?
All real numbers.
Domain here is all real numbers. Agreed. Goes to the left forever, goes to the right forever. Lexi, what would our range be?
Parentheses, -3, comma, -5,
Mm-hmm.
bracket, union, bracket, +1, comma, +1, parentheses.
Beautiful. Nicely done. Huh? Tim, you okay with all that?
Yep.
All right. Tiff, you're good? Okay. I'm actually going to have you just do some practice problems. It is in your textbook, but you should have enough time to, oh, wait, no, but it's almost time to go. Okay, so on your final study guide, I'll put maybe a couple of these on here. If I did something like that on the final, like I would give you this template, okay? It'd be like, here's the formula, use these numbers, make me a hyperbola.
Cool.
Okay, all right. So we are officially done, guys. That's fun.